Okay, this problem says the acceleration of a particle is a constant. At t equal to 0, the velocity of the particle is 10I plus 220j. At t equal to 4 seconds, the velocity is 10j. What is the particle's acceleration? So, since the acceleration is constant, the acceleration is given, average acceleration is equal to the instantaneous acceleration, and that's equal to change in velocity over time. Okay, so the acceleration is change in velocity is v final minus v initial over the time over which this change happened. Okay, so at 4 seconds it's 10j minus 10I plus 20j, and these are in meters per second divided by 4 seconds. Okay, so this would be minus 10I, and 10 minus 20 is 10 minus 20 is minus 10j. Minus 10j and divided by 4 meters per second square. And so the acceleration is minus 2.5I minus 2.5j meters per second square. Okay, so now we have the acceleration of the object. How do the position and velocity vary with time? Assume the particle initially is at the origin. So what they're saying is not x naught, okay, r naught, the initial position, is given by x naught I plus y naught j, which is 0I plus 0j. That's what they're telling you when they say the particle is initially at the origin. Okay, so you can see from your notes that the final position is equal to initial position plus initial velocity times time plus 1/2 a t squared. This is when this is true when the acceleration is constant. So you can see this in your notes. This is, by the way, this is the final position. All right. So, and the velocity is given by initial velocity plus acceleration times time. Okay, so that's what position and velocity as a function of time are. Okay, let's add a page below, and then we'll write that out. Okay, so again, part B continued. R final, or not R as a function of, we'll say R as a function of time. R naught is 0. Alright, I'll write it. R naught plus V naught t plus 1/2 a t squared. And this is 0I plus 0j plus V naught is initial velocity is, so there's the initial velocity at t equal to 0. The initial velocity is 10I 20j times t plus 1/2. The acceleration of the particle is, we calculate minus 2.5I minus 2.5j minus 2.5I j t squared. Alright, so if you add up all these vectors, so add up all the I components, that's 10I t, 10t, and this is 1.25 t squared. Okay, so 10t minus 1.25 t squared I plus the y components are 0 plus 20t minus, so 20t minus 1.2 t squared j in meters. So that is the position of the particle as a function of time. And if you wanted just the x coordinate, the x coordinate as a function of time is that, and the y coordinate of the particle as a function of time is this 20t minus 1.25 t squared. And again, these are in meters. Okay. All right. Well, let's add another page for as far as the velocity as a function of time goes, it's v naught plus at, and v naught was, as you saw, 10I plus 20j, and acceleration is minus 2.5 I plus minus 2.5 j times t. So this would be 10 minus 2.5 t I plus 20 minus 2.5 t j. So here's the x component of the velocity, here's the y component of the velocity. So this is the velocity as a function of time. Okay, and that completes the problem.